national stadium in which the Tokyo Olympic swimming and diving events were held was completed in August 1964. It has a seating capacity for 15,000 people and is a structure composed of a complex suspension system. The structural system. The main columns, 40 meters high, 130 meters between the tops of grandstands, 126 meters between the main columns, and 230 meters between the anchorage blocks. The total floor area is 29,880 square meters. In the center are diving and racing pools. At each end of the two pools are two main columns, 40 meters high, and crescent-shaped stands circle the pools. From the anchorage blocks, the two main cables are strung over the columns. These cables are 280 meters long. The main cables are pulled apart to form a spindle shape to provide space for skylights and ventilation. On this, a monitor roof is placed. A total of 74 hanging members are suspended between the main cables and grandstands. Bracing cables are strung and then the roofing is placed. A cross-section of the grandstand shows that it protrudes over the ground and so would tend to rotate. But the hanging members prevent the grandstands from rotating outwards. Upon completion of the stadium roof, the tension in the main cables is expected to be about 3,000 tons. This force is transmitted to the anchorage blocks. At the anchorage blocks, tie beams are used to resist the horizontal force, and the weight of the blocks counters the lifting force. Anchorage blocks and grandstands. The work on this gigantic project was started in February 1963. The first stage was the construction of the anchorage blocks and grandstands. Concrete pumps were used to pour concrete for the anchorage blocks. The weight of each block was 3,000 tons. Between the anchorage blocks, two tie beams were placed. Simultaneously with the construction of the anchorage blocks, work on the grandstands was started. There are 41 steps in each grandstand. Here again, concrete pumps were used to pour the concrete. During the construction of the grandstands, they were held in place by a maze of temporary shorings. Complicated curves were used in the design for the exterior of the grandstands and so each formwork for this section had to be made individually to produce the desired curvatures. The concreting of the grandstands was completed in December 1963. Main columns and saddles. The second stage of this project was the construction of the main columns and installation of cable saddles. The main columns, each 40 meters high, would be subjected to a compression force of approximately 2,500 tons each. On top of each main column, where the cables were to rest, cable saddles were to be installed, but these saddles posed no small problems. With the weight of the hanging members and roof covering, the central portion of the main cables would sag, and the slack in the backstay portion would lessen. As a result, the cable saddles on the columns would have to move inwards. Moreover, there was the possibility that when the main cables were pulled apart to form the spindle shape, the cables would twist and cause unfavorable stress inside them. The saddles had to be designed to eliminate this possible deformation of the cables. Specially designed cable saddles were made to act with both the slack and the torque movements. These saddles were finished on a giant turning machine. The cable saddles were installed during the winter of 1963. During their installation, in order to reduce friction between moving parts, special lubricant was applied. Two sets of cable saddles were installed on each column. These were offset 235 millimeters and 271 millimeters outwards, and inclined inwards 18 degrees 37 minutes and 17 degrees 22 minutes respectively. Main cables. Next came the stringing of the main cables. The main cables were composed of 31 52mm cables and 6 34.5mm cables, which were bundled together. All 37 cables were cut to a calculated length at the factory, and on each end steel combs were attached with which to fix cable ends onto the anchorage frame. After the cables were cut to length, they were pulled and stretched for 2 hours under 100-ton pressure. Then the exact locations of the cable saddles and connections were marked. While this work was being performed, a cable stringing crane and suspension catwalk were being installed at the construction site. From the spools near the east anchorage block, cables were unreeled by winch and pulled up to the top of the east column. From here, the cable stringing crane took over and brought the cable to the west column. And here, the winch near the west anchorage brought the cable to the west anchorage block. Then the cable end was fixed temporarily on the anchorage block frame. Thus, all 37 wire ropes were strung. But during this operation, in order that the tension in the main cable would be distributed evenly among constituent wire ropes, they had to be carefully adjusted. To avoid the heat of the sun, the ropes were adjusted during the night between 10 p.m. and 3 a.m. The method of adjustment was to apply 30-ton pressure on each wire rope with the use of hydraulic jacks, and then to fill in the space between the end cones and anchorage frame with shims of varying thicknesses, so that the tension in all wires was equal. It took approximately a full month to string the cables. With the completion of this, the most critical phase of the project was over. Cable straps. The function of the cable straps was to hold the cables in shape and to provide a means of tying the hanging members and monitor trusses to the cable. Each strap was composed of 3 parts: strap, ball, and socket. The ball and socket joint was used for flexibility between the cables and hanging members. A torque wrench was used so that all straps could be fixed onto the cable under even pressure.